Hi, my name is Katie Stewart, and I had my 4th grade classroom build an anemometer. Basically, my students created their own anemometers, which are instruments for measuring wind speed. We looked at how anemometers measure wind speed by taking measurements at various locations around our school. We learned about different types of anemometers, real-world applications, and how wind speed information helps engineers decide where to place wind turbines. We then looked at how our activity aligned to STEM practices. Students first began by asking questions. We talked about why would we study the weather? Who studies the weather? We looked at meteorology, looked at weathermen, and why it is important to know the weather ahead of time. We looked at the models that weathermen use. We also looked at the tools that weathermen use, barometers, anemometers, and how those are important in studying the weather. So then we decided that we were going to build our own anemometer. So students used the engineering design process to build their anemometer. We then went outside and collected data using our anemometers, and then we analyzed that data to determine which location on the playground had the fastest wind speed and which one had the slowest wind speed. Students then had to construct an explanation determining where would the best place be to put an actual wind turbine if they were an engineer determining where wind turbines should go. This also aligns to science inquiry. Learners first looked at scientifically oriented questions such as why do we study the weather? We also looked at, once we had built the anemometer, we looked at the evidence and we saw that the wind was faster on the north side of the playground. And so students were able to determine, well, if the wind is faster there, what does that say about the weather? What does that say about the day? What does that say about where we should place a wind turbine? And so they had to formulate explanations from their evidence, and then they had to use the knowledge about wind and wind speed to explain why a wind turbine would go there. Then they had to communicate with the class why their group thought that the wind turbine should be placed there. So looking at the engineering design process, this relates specifically to building the anemometer. So we talked about the different questions, and then we went into imagining and planning what their anemometer would look like. So students brainstormed ways to measure wind speed, what the anemometer would look like. Then they had to first complete a sketch of their imagined anemometer. I actually chose not to show them any pictures ahead of time of what anemometers look like. I was looking for their creativity in this and what they could come up with. Students then used the available materials to create their anemometers, and we went outside then to test the anemometers, and they were given the chance to come back in and improve their designs. Many students were very grateful for the opportunity to test because most of the anemometers did not work on the first try, but they were able to look at their models and determine what went wrong, and then we came back inside, improved them, went back outside, and the majority of them worked the second time around. We then used a stopwatch to collect data, and I don't know if the video will run, maybe not. There is a quick video here of this anemometer running, and they used their stopwatch, the anemometer spun, and they counted how many rotations it made during a minute. We then analyzed the data and explained why the data was the way it was. We looked at different parts of the playground. Students would formulate explanations as to why locations were windier than others. We talked about our building, our school building, and maybe it blocked the weather. And then we determined the location that would best work for a wind turbine, which was in the north part of the playground. And that is the end of my presentation.